Hello everyone, my name is Alma Dilis and I am a software engineering student at Makerere University Year 2. Welcome to my YouTube channel, and today I'm going to be talking about some critiques of AI, and let's go and see what we have today in our video. We are going to start on by looking at the early days and history of AI, but first of all we are going to define what AI is. In my last video, which if you did not watch, I've shared the link in the description below so you can be able to watch it. I define AI as the science and engineering of making machines that are intelligent. And today yes, I'm still emphasizing that part of intelligence. So today I'm defining AI as the field devoted to building artifacts capable of displaying behaviors we consider intelligent. There are basically 4 dimensions of AI, and in these 4 dimensions, we are able to tell whether computers think humanly, act humanly, think rationally, or act rationally. And we shall also be looking at some artifacts of AI like natural language processing, knowledge representation, automated reasoning, machine learning, computer vision. We are going to leave out robotics because it's not part of the system we are dealing with. We are going to see how they are incorporated into the system that we are using and how they are incorporated into AI. So let's look at the audience engagement analytics. So in the last video, I introduced the system we are working on, which is the audience engagement analytics, a system which is able to detect facial movements and tensions in the muscles of the faces and match them to a given set of emotions. For example, happiness, sadness, someone is bored, yes, all those emotions. And let's take a look at how that system and the computer vision, the different artifacts or the different branches of AI are involved in each other. So let's look at computer vision. Computer vision, I can say it's the heart of the system we are developing because, yes, the webcam or the video feeds have to detect the face and also the landmarks. The landmarks, I mean, let's say the lips, the nose, the eyelids, and all that. So these landmarks are basically the ones that are able to tell us the facial expressions or the emotions are the ones we are able to match to the different sets of emotions. Then let's look at machine learning. In machine learning, we are able to feed in our data to the system. The system will learn from it and then it will give us feedback. Yes, or another time when we're using it, it will just use that data we have given it to make inference and prediction of the emotional state of the audience. Then natural language processing, um, yes, the language we speak needs to be converted to the machine language so that the machine is able to learn and so that the machine is able to understand it in its own way, not the way we humans understand. And let's say the machine or the system has detected an emotion in the audience, or it wants to give us a report. Yes, let's say it will not give us a report in the language in which it understands because we humans do not understand it. It needs to be translated into meaningful sentences that we understand, and that will be in our language. So that's the work of the natural language generation. Let's look at knowledge representation and automated reasoning. Knowledge representation is the one that provides the intelligence behind the system. It has a set of rules and knowledge which the system bases on to give us a feedback. And that knowledge is got from the data we feed the system with. Automated reasoning is the one that makes decisions and inferences and prompts the speaker. Let's say the system ensures a number of factors to warrant a specific response. For example, how much time is the speaker spending on a given slide during a presentation? And uh, it will compare it to the average emotions. It's the average performance of the audience. Let's say 70% of the audience, like 70% of them are already bored and the speaker is still on that slide. So it will be able to decide and give the speaker a prompt saying, your people, your audience, the people are bored, move to another slide or do something for them. Let's now look at the four dimensions, and we're starting with can computers act humanly? Like, is our system able to act humanly? When you talk about acting humanly, this is majorly based on the Turing test. And here we are looking at if we can create systems that can act in a way that is indistinguishable from human behavior. Is our system able to tell us the emotions of the audience, to give us feedback in a way that is indistinguishable from human beings, or in a way that we cannot tell whether it's a human being or not? Yes, I strongly say yes, because I can consider actually the system to be a human assistant because it provides real-time feedback. Because the system, what we are emphasizing on as the feedback is the outcome and the impression it leaves. So if it gives us the impression that yes, the people are sad, and it is true, so I can strongly say that the system acts humanly. Can the system act rationally? Yes, we are looking at building an intelligent agent that acts to achieve the best possible outcome given its knowledge. Is our system able to do what we built it to do, or what we constructed it to do? Yes. My answer is still yes. So that means our system is able to act rationally. Can our system think rationally? Here we're looking at systems that think logically and make correct inference. It relies on the principles of formal logic and reasoning to guide decision making, adhering to strict rules of logic to arrive at valid conclusions, regardless of human cognitive limitations. So the audience engagement analytics uses automated reasoning, and its dashboard analytics output from facial recognition model combined with other logical premises, such as how long a speaker has spent on a slide to produce a score. I think I talked about this somehow, somewhere before I reached this point. So it will use the output from the facial recognition model. Yes, the audience, let's say 30% of them are annoyed, and I already mentioned the part of being bored. Let me talk about let's say 70% of the audience is happy right now, and the speaker has spent, let's say, 5 minutes on a slide, and the speaker is still explaining, and we're seeing that as the seconds are going, as the time is moving on, the happiness is increasing. So yes, basing on that, people are happy. The speaker is spending more time on a particular slide. So it will actually enable the system, or the system will be able to give feedback basing on uh, how the audience is being engaged, how they're happy, and then how much time the speaker is spending on a particular slide. Thinking humanly. So here, uh, can the system understand and replicate the way humans think and process information? So here we use cognitive science. If I say cognitive science, I mean majorly we are looking at building models that mimic the human mind or that work like the mind, or systems that look like the mind and works like the mind. So the process of thought itself, attempting to simulate the internal cognitive mechanisms. By this I mean the system is able to do the things that the mind is able to do, or to think and act like the mind. So our audience engagement analytics, it just attempts to understand human mental state, and it uses this understanding to categorize behavior. The system is built to interpret human internal state, and these are emotions. The human internal state are the emotions. The system is built to interpret this basing on the data that we have fed it with. But I can strongly say that the system does not think humanly. It just tries to understand. Okay, it understands, yes. It just understands the data that we have fed it with, and then it uses that to categorize behavior or to categorize the emotions. Let's look at production systems. Production systems, they're also known as production rule systems. These are the core AI architecture that captures the essence of AI by replicating human problem solving skills through a set of rules and facts. How they work, we're going to look at how they work, and then also how they work in the context of the audience engagement analytics. So they consist of a rule base, those are if then statements, a fact set, that is the working memory, and an inference engine that applies rules to facts to reach conclusions, much like how a human makes decisions based on available information and experience. This allows production systems to perform tasks such as data analysis, identifying bottlenecks in manufacturing, and facilitating intelligent decision making in real world scenarios. So, how does it apply to our system? The working memory is a real time blackboard that holds the current facts about presentation and the audience. This data is constantly being updated by the computer vision and machine learning models. The real time blackboard, I mean, is things are happening on ground, things are happening with the audience. There's I can call it mood swings. Right now they're happy, in the next second they're sad. Right now they're laughing, in the next second they're bored. I mean, their face is showing neutral, and this keeps on changing. The emotional states of the audience keeps on changing, but this data needs to be captured every second, and the data is being accumulated with time. So this is done by the computer vision and machine learning models, but this data needs to be held. So the current facts or the emotions of the audience is being what is being recorded every second, every time. And when we look at the production rules, these are the core of the system's intelligence. They are logical states that define the behavior and conditions under which it should take an action. Um, the states and the rules here, I mean, the audience is happy about something. Let's say a presenter is presenting a particular slide and people are bored. So it will base on how much time the presenter is spending on that slide or has already spent on that slide, and the emotions of the people to give a feedback or to make a decision and then prompt the speaker. The inference engine is the brain that drives the entire system. It operates on a continuous loop, executing a recognized act cycle to manage the working memory and the production rules. The inference engine here, I mean, if people are sad, then what should I do? The recognized act cycle is still the same. If people are happy, then what should I do? And it's always continuous. If people are sad, do this. If people are happy, do this. So that is the brain that drives the entire system. We are going to look at how heuristic functions are formulated. Heuristic functions are functions used in computer science, particularly in AI and search algorithms, to provide an educated guess or best guess of the cost to reach a goal state from a current state, thereby guiding the search process towards the most promising path and making it more efficient. Here, it's just a measure of how close you are to the goal. Like, if you take this step, if you take these procedures, how close will you be to reaching the goal you want to achieve? A heuristic function estimates the cost or distance to the goal. Yes, I already talked of that. In such algorithms, the heuristic function guides the selection of which path to explore next. We have all these like procedures. So there are different ways of solving a problem. If I take on one way and leave at the other, okay, if I look at each step involved in the different ways, after a particular step, how close will I be to achieving my goal? They are the core of informed search strategies, contrasting with uninformed search algorithms that lack any guidance and explore any possibilities systematically. Let's take a look at knowledge and reasoning. Knowledge representation is a field of AI that focuses on designing computer representations that capture information about the world that can be used for solving complex problems. And here we're going to take a look at the first order logic, which is also called the predicate logic or the predicate calculus or quantificational logic. It's a collection of formal systems used in mathematics, philosophy. Right now, we are talking about computer science and even software engineering. Software engineering originated from computer science. So, the first order logic uses quantified variables over non-logical objects and allows the use of sentences that contain variables rather than propositions such as all humans are mortal. In first order logic, one can have expressions in the form of for all. Here, I have illustrated this in the next slide, which is this. So, here, I talked of predicates. So these are functions that evaluate to true or false. They define concepts for the system. For the system's core concepts, for example, is happy, and let's say a person is happy. It will return true if the person is happy and false if the person is not happy. And here we use variables and quantifiers such as for all x, and we use this particular sign for all x, the symbol. And let's say there exists a person in the crowd, and that we are going to use this symbol to represent there exists a person. There is also automated reasoning with first order logic. So we write formal logical synthesis that the system can use to reason and make decisions. For example, if for all people we use this symbol in the audience, they are happy. Everyone is happy in the audience, and the slide has been on screen for a long time, then the system can conclude that the current slide is an effective one. So I'm going to stop here for today's video. Let's meet again in the next video. But remember and don't forget to watch my last video, and please subscribe to my YouTube channel. Like and subscribe and share it. Feel free to share. Thank you.